Hi everybody. In this video we are going to talk about the change of base formula. And here it is. So if we have the log of some number to some base over here, then that's the same as the log of that number to some other base divided by the log of what used to be the base to that same base that we used up here. So we're changing the base. In this example, I used the letter C for the original base. We're changing it to some other base, and then the old base becomes just one of the other numbers in here. So let's do a proof of this, and then we'll do some examples. So again, like we did in the last video, I'm just going to have some number lowercase a. And if I take the log of that base C, then I would get some number for that. And I'm just going to call that number capital A. Now, if I know that the log of little a base C is equal to capital A, then I can also write that that C raised to the power of capital A is equal to little a. Okay, I'm going to leave a little bit of space here. You'll see why in a second. Okay, so that goes back to just our, what a logarithm is. So now I have an equation here, and I'm going to fiddle around with this equation a little bit. Now, when you have an equation, I know you're very used to looking for something specific in the equation to tell you what to do. So for example, you've probably seen equations like this a million times, and you look at that equation and you say, oh, I see a +3 here. That means I have to do -3. Okay, but really you can do whatever you want to an equation. If two things start out equal to each other, then as long as you're doing the same thing to both of them, regardless of what you're doing, then both sides would still be the same. So what we're going to do over here is we're just going to do the same thing to both sides, not because we see anything that tells us that we have to do this, just because we want to do it. So what we're going to do is take the log of both sides to some other base, which we'll call k. Okay, so what if we take the logarithm of this side, base k, and then we do the same thing to the other side. Okay, since both sides started out the same and then we did the same thing to both of them, then both sides are still the same. So what we did was nice and legal. Okay, now what we can do over here is we can rewrite this using the power rule that we learned about earlier. Oops, here it is. Okay, which says that if we have an exponent in here, then that exponent can become a coefficient. So we can rewrite this as capital A times the log of C base k. Okay, so we took that exponent and we brought it over here as a coefficient now. And then this is still the same. Okay, I didn't have to do anything to this side because I didn't actually change this side over here. I changed the way it looked, but these two things are equal to each other. So the value is still the same. So I didn't need to do anything to the other side. Okay, now what we can do is, again, because we want to, not because we have to do it, but you'll see that what I'm about to do is, it turns out to be useful in the end. It'll bring us to the quotient rule. Sorry, not the quotient rule, the change of base formula. Okay, so I want to get this a by itself. How can I do that? Well, this a is being multiplied by this, so we'll just divide. So we'll divide by the log base k of c, and we will do that to the other side. Okay, so these cancel out. I know that looks very messy, but they just cancel out. And so we're left with just a over here. And then on the other side, we have the log base k of little a over the log base k of c. Okay, and by the way, just a reminder, this k is just some other number. Okay, doesn't really matter too much what number it is. There are some exceptions. So the base of a logarithm can't be 0, it can't be 1. I'm going to talk a little bit more about that in another video. But basically, what we did over here when we multiplied both, when we took the log of both sides, it really didn't matter what number we chose for k. All right, so anyway, now we're down over here. So we have a is equal to this. But remember what a is. A is just the log base c of little a. So I ran out of space down here, but we can just substitute this for capital A. And then if we replace this with this, we would get the log c little a here equals this. Okay, and that is exactly the change of base formula that was written over here. Okay, so let's do, you know what, let's just do a couple of examples with that, and then you'll see how it's useful. So if I want to figure out what the log of 64 is, base 16, how could I do that? Well, so I'm thinking of 16 to what power is equal to 64? Well, let's try 2. 16 to the second power means 16 times 16, but 16 times 16 is already 256. Okay, we've already gone way over the 64. So this doesn't seem like such an easy problem to solve just by thinking of what exponent above 16 would give us 64. But we can use the change of base formula over here, and that would make it a lot simpler. So we might notice that both 16 and 64 are powers of 2. So we can use 2 as our new base. We can choose 2 to be the base k over here, and then the 64 would just go over here, and the 16 would just go over here. So we can rewrite this as the log base 2 of 64 over the log base 2 of 16. Okay, really it'll work with basically any number. There are some exceptions, which I mentioned a little earlier. I didn't have to choose 2, but I chose 2 because I can see that 64 and 16 are both powers of 2, so this will be easy to evaluate. So now I can ask myself, 2 raised to what power is equal to 64? I think we did that in the last video, and that's 6. 2 to the 6th power is equal to 64. And now I ask myself, 2 to what power is equal to 16? And that would be 4, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. So 4. 2 to the 4th power is 16. Okay, so now we have 6 divided by 4, which is 1.5. All right, and there it is. And like I said before, we didn't have to choose the number 2. I chose the number 2 because it was convenient. But actually, another convenient number that I could have chosen is 4. 64 and 16 are also both powers of 4. Right? And you'll see we'll get the same answer. So 4 to what power is 64? Let's see. 4 times 4 is 16, times another 4 is 64. So that's 3. 4 to what power is 16? That's 2. And 3 divided by 2 is again 1.5. So we do get the same answer no matter what base we choose over here. So it's kind of neat. We started with a problem which was pretty hard to solve. And then what we did was we just put this number over here and put this number over here, and then chose any base which was convenient for us. and we found the answer much easier. And by the way, this does, so 16, what we just learned is that 16 to the power of 1.5 is equal to 64. And you might be wondering, what does 16 to the power of 1.5 mean? That actually does have meaning. We haven't talked about it in these videos yet, but let's look at it as a fraction 3/2. What it means to take some number, 16 in this case, and raise it to the power of 3/2, it really means that we take 16, we raise it to the third power, and then we take the square root of that. Okay, and we can do that real quickly in a calculator over here. So 16 to the third power, 16 times 16 times 16, that's 4,096. And then if we take the square root of 4,096, so we ask ourselves, what number times itself is 4,096? That would be 64. Okay, so 16 to the power of 3/2, or 1.5, is actually equal to 64. Okay, so the change of base formula worked. We had 6/4 earlier, you might remember. If we did this same sort of thing, if we did, just going back to what we said earlier, where this was this was a 2, this was a 2, this was a 6, and this was a 4, then that would also work. So 16 to the power of 6/4 means take 16 multiplied with itself, 6 times, 16 to the 6th power, and then take the 4th root of that. So then you would have to ask yourself, whatever you get over here, you would have to ask yourself, what number multiplied with itself 4 times gives us that number that we get over here? So I'm not going to do that in this simple calculator over here, but you would get the same answer again. You would get 64. All right, one more example. Okay, again, if I want to do the log of 100,000 with a base of 100, so I'm asking myself, 100 raised to what power gives me 100,000? Well, let's see. If I did 100 times 100, that would be 10,000. So I'm a little under, right? I want 100,000. If I multiply by, so that was 10 to the second, sorry, 100 to the second power. If I multiply by 100 again, this was 10,000 times another 100, that would give me 1,000,000. No, too much. I wanted 100,000. So it doesn't look like this problem is very easy for us to solve in our heads either. But we could use the change of base formula. We could say that this is equal to the log of 100,000 over the log of 100, and then we would just have to think of some convenient base to use over here. Well, 100,000 and 100 are both powers of 10, so 10 is a pretty convenient base for us to use. Let's see, 10 to what power is 100? That would be 2. 10 to the second power is 100. 10 to the 5th power is 100,000. Okay, so the answer here would be 5/2, or if you want to write it as a decimal, 5 divided by 2 is 2.5. Okay, and so what this means is that 100 to the power of 2.5 is 100,000, or in other words, 100 to the power of 5/2 is 100,000, which literally means we have 100, and we're going to raise that to the 5th power and then take the square root of that. And what would that give us? Let's see here. So 100 to the 5th power, we would end up with 10 zeros there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we do 100 times 100, 5 times, okay, that would give us 10 zeros. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we would need to take the square root of that. So we're asking ourselves, what number times itself is equal to, what is this, 10 billion? So that would be a 1 with 5 zeros after it. If we multiplied with itself, then we would get 10 zeros. So the square root of this would be one with 5 zeros after it. That would be 100,000, which is exactly what it says over here. Okay, so 100 raised to the power of 5 halves is 100,000. So it works. All right, and that is the change of base formula. I'm going to end the video there, and have a great day.